Okay, guys, so integration by substitution, this is what we're doing. If you look at the method that we're told to do here, it says if we want to find the integral of h of x times f of g of x. F of g of x means we have a function and something else is happening to it. So to do this, here's the method that we can use. Our book just tells us to rewrite it in this form, but that's pretty tough to do. Doing it this way will make it quite a bit easier. We're going to choose a u value so that when we take the derivative, that's what du means, the derivative of u, has to be similar to the other part of the problem. So it says that we're going to let u equal the inner part of a composition of functions. So wherever we have something happening, like right here, we have a function and it's getting raised to the 5th power. So in this problem, that's going to be our u. After we determine what u is, we have to find du. What did I just say du means? Derivative of u. Then we have to rewrite the integral with u and du, because we have to have matching variables in order to integrate. We're going to integrate in terms of u, and then we go back and we replace u with whatever we let u equal to. All right, so let's look at the problem. So, what did I just say we would let u equal? Dominic? What's inside? Okay, and that g of x means whatever's inside the parentheses. So what's it going to be? Right. And then we said we have to find the derivative of u. And the derivative of u is just the derivative of this. And so what's that going to be? Emily, what's that derivative? Right. We have to say 4x cubed dx. The reason I have to do that is because I'm using implicit differentiation. The derivative of u is 1 du. The derivative of x to the 4th is 4x cubed dx. So now I look back at my problem, and here's 4x cubed dx. What is another name for 4x cubed dx? It's just du, isn't it? See how right here it says du is 4x cubed dx? So this 4x cubed dx is just going to become du. So this is now gone. 4x cubed dx is now gone because I replaced it with du. Now, what's another name for x to the 4th minus 1? U. And what is happening to the u? It's getting raised to the 5th. And in our warm-ups, we did this problem. So you should remember how to integrate this. What's the integral going to be, Anna? Okay, so that's u to the 6th. Okay, divide by 6, or I can even put 1/6, right? I prefer to put the 1/6, plus c. And so that's going to be our integral. But we're not trying to integrate this with respect to u. We're trying to integrate this with respect to x. So now I have to go back and say, okay, well, what is u? U's right here. Okay, so I'm going to have 1/6. Here's what u was. 1/6 u, I wrote that to the 6th plus c. And so that's going to be our integral. I could quickly check this by saying, what's the derivative of this? Don't even write this down, but just think about it. The derivative of this, I'd have to do 1/6 times 6, that's 1, u to the 5th, times the derivative of the inside. I'd have to use the chain rule. And I would get back that if I did it. Okay. So when we're integrating, it means what is the function that has this for its derivative? And the function would be this. All right, so looking at number 2 now. First, we want to rewrite this so that we have a parenthesis. So I'm going to rewrite this as the integral of 8x times 1 plus 2x squared to what power? 1/2. And then we just said that u is going to be, most of the time, whatever's inside the parentheses. Here's the parentheses. So we're going to say then that u is 1 plus 2x squared. Abigail, what's the derivative here?
4x dx.
Okay. Everybody see that? The derivative of u is 4x dx. Now look at what we've got. Right here, this is our u. So that's going to be u to the 1/2. I have to get rid of the rest of the problem. Oops, why did I write du? That should be dx. I have to get rid of 8x dx. How do I get rid of 8x dx when I have 4x dx? Right, good job. So 2 du is going to be equal to, multiply this by 2. So 2 du is the same thing as 8x dx. All right, so here's my 8x dx. All of that gets replaced with 2 du. I'm going to spread it apart. And the reason why I do that is because I have to replace this. And what's another name for this? Look at our list. Another name for this is just u. So it's u to the 1/2. And so now we just have to integrate this. Sean, can you tell me the integral? Good. So I add 1 and I get 3/2. Then I had to multiply by the reciprocal, so I had to multiply by 2/3, and that's 4/3 plus c. Brandon, did you have a question?
Can you tell me how you got from one above that to that one? You know, how'd you get from 2 du to x gets to 1?
To this? Okay, so I'm looking at the problem 8x dx. Here's my 8x dx. So 8x dx is 2 du. So this is now gone. That got replaced with 2 du. This right here is just u. So it's going to be u to the 1/2. So another name for this was just u to the 1/2. Any other questions? Now, we are not finished with this, though, because this has a u in it. We were trying to integrate with respect to x. So I have to look back and see what u was. See, with these directions, it says replace u with g of x. G of x is just what's inside of those parentheses. So here's g of x. So we're going to have 4/3 u to the 3/2 plus c. So once again, look at the process. We find u. It's what's inside the parentheses. I take the derivative of u. If it doesn't match, then I have to think, what do I need to multiply it by to make it match? Well, I had to multiply it by 2 to get that 8x dx. So now instead of replacing with just du, I had to replace with 2 du. Okay? Yeah, Sean.
Is there ever going to be a time when we have to multiply that answer fully out for like anything, even multiple choice?
No. No.
That's the
Right. See, and that's why we have this whole method, is because if I had to integrate this, I would have to raise this to the 5th power, which would mean expanding it out, and it would be like that long to expand, which would be ridiculous. So with this u-substitution, we can easily and quickly get the integral without having to expand. All right, let's look at number 3. Now, first thing I want to do is rewrite this as a product. See how this original thing says we have to have h of x times f of g of x? Well, right now I have h of x divided by f of x dx. So I have to rewrite this as a product. So it's going to be 3x times 1 minus x squared to the what? Negative 4, right. So that's just a rewrite of my problem. So now we have to figure out what's u going to be. What is u going to be? All right, 1 minus x squared is whatever's inside of those parentheses. So now I have to take the derivative of u. The derivative of u is going to be negative 2x dx. But look at what we wanted to get. See, here's our u to the negative 4. This is the leftover stuff that I need to get rid of. I have a 3x dx, and here I've got a negative 2x dx. How can I turn negative 2x dx into 3x dx so I can get rid of it? Negative 1/2. Okay, so if I multiply this by negative 1/2, will I get 3x dx? You're close. Yep. See, Jacob? Yeah, you're right, though. You're thinking right. It's just that we also have to use a 3, don't we?
Yeah.
If we multiply this by negative 3/2, see, look, guys, if we multiply by negative 3/2, now these 2's cancel. A negative times a negative is a positive 3x. That's what we needed to do. Okay? But you're right. We had to get rid of the 2, but we had to get a 3, so we had to get rid of the 2 by dividing and get the 3 by multiplying. Yep. So now we've got negative 3/2 du is equal to 3x dx. So we look at our problem. Here's our 3x dx. What am I replacing that with again? Right, so it's negative 3/2. I can pull the negative out in front. Du. Here's my u to the negative 4. You can pull the negative out in front. You can even pull this coefficient out in front if you want to. Okay, so either way, we're going to add 1 to negative 4. What do we get if we add 1 to negative 4? Negative 3. So now I have to take my negative 3/2 and I have to divide it by negative 3, or I can think of it as multiplying it by what? Negative 1/3, right? So, everybody with me there? I added 1. I got negative 3. So I had to divide by negative 3, but that's the same as multiplying by negative 1/3. It's just an easier way to do it. So what am I going to have then for this coefficient? Just 1/2 u to the negative 3 plus c. I have to replace my u now, though, with what it is. So this is going to become 1/2 u to the 3rd plus c. Do you see why I did that? Why did I write it like this? To get rid of negative exponent, right? So if I were then to take this derivative and do the chain rule, I would end up getting that. That's what that means. All right, questions so far? Okay, so we're kind of building. We started with an easy one. On your homework, 7 and 9 will be just like number 1. It'll build. Then you're going to get to a type like this on 11 and 13, and then as you go, you're going to gradually get to these more difficult ones. So let's try number 4. Alina, what do you think u should equal? It's whatever's inside the parentheses that has something else happening to it. So what's it going to be? Is it 1 plus 3 over x or 1 over x squared? Nope. It was the way that I said that that led you that way. But see how this is to the 4th power? So this is going to have to be our u. See, anything that has something else happening to it, like this was to the 1/2 power. This was my u. this was to the 5th. That was my u. So in this case, this is to the 4th. So that has to be the u. So 1 plus 3 over x has to be the u. Jared, how can I rewrite that, though, to make it easier to take the derivative?
That would be the 1 plus 3x first.
Right. And so now I can take that derivative. So the derivative of u, the derivative of 1 is 0. I do 3 times negative 1, that's negative 3x, subtract 1 is negative 2 dx. All right. Look at what we have, though. We're trying to get this to go away. This is 1 over x squared. Is this even close to 1 over x squared? It actually is, guys. Look. I need to quit making you think. Isn't this pretty close? Negative 3 over x squared is close to 1 over x squared, right? So what do I do to both sides to make it so that it is the same? Divide it by negative 3, or what Brandon said, multiply by negative 1/3 on both sides. So we have negative 1/3 du. This is going to simplify now. See what I'd have? Negative 3 times negative 1 is 3 over 3, which would just be 1 over x squared dx. See that? Who can tell me how I rewrite the problem now? How would the integral turn in? What would it turn into? All right. Negative what in the front?
1/3.
Yeah, so negative 1/3 du, okay? So that took the place of all of this, didn't it? 1 over x squared dx, this is now gone. You don't have to put the negative 1/3 in front. You can put it here too if you want. You can put it either place, it's a constant. Chad? Right. See that? Right here's u. So it's u to the 4th. Okay, so now let's finish. How do we finish it? Lydia, what's the integral of u to the 4th? Good. So I've got negative 1/3, and she's right. This integral is 1/5 u to the 5th. So now we're going to have negative 1/15 u to the 5th. And then what do we have to do just to be completely finished? Plug in u, right. So negative 1/15, find the u. It's back up here. Replacing our u with this to the 5th plus c. And that's going to be our final answer. Okay, questions? All right, we're going to go right into this. Open your book. We're going to get some of these finished before you go, because you have to practice it now. It's one of those